So welcome to the MLOps Live webinar series, your go-to space for exploring how to bring data science into production and generate real business impact with AI. We're excited to have you here with us today for what promises to be a really insightful session. I'm Idit. I'm the head of community and open source marketing at Iguazio, an AI startup that was acquired by McKinsey in 2023. Today's topic is about building AI co-pilots for proactive call centers. We'll be diving into how generative AI-powered agents, co-pilots, can transform call centers from being reactive support hubs into proactive revenue-generating engines. We'll explore building these co-pilots at scale, ensuring their performance in production, and leveraging post-call analysis for continuous improvement. I'm excited to introduce our first speaker, Guy Lecker, ML Engineer Team Lead at Iguazio. Guy will walk us through the development of a Gen AI-powered call center co-pilot, sharing the client requirements, use cases of agents, selling health insurance, and a preview of the demo highlighting the system's workflows, UX, UI, and future roadmap. After that, we'll take a quick break for a poll, and then Nick Scanoni, Senior ML Engineer at Iguazio, will show the demo of the co-pilot in action. He'll break it down, the client requirements, how they were translated into specific tasks, and walk through the code examples that bring those tasks to life. We'll take another short break for the second poll. And of course, we'll wrap things up with a live Q&A. So feel free at any moment throughout the webinar to drop your questions in the Q&A section of your screen as we go along. Now, a few housekeeping items before we begin. This session will be recorded and a link will be shared with you afterwards. Don't worry if you miss anything, we've got you covered. As I mentioned, we'll be taking your questions at the end of the webinar, so please make sure, not in the chat, to use the Q&A tab at the bottom of your screen so that we don't miss your questions. We've added 2 polls, as I mentioned, during the session, and your input is very, very valuable in shaping these webinars. So we do encourage you to participate. We'll also share the poll results live at the end of the webinar. And lastly, we invite you to join our MLOps Live community to keep the conversation going after the session. We'll share the link in the chat for easy access. And now, without further ado, I'm going to hand it over to Guy to get us started.
Everyone, let me share my screen. Okay, excellent. So, hi again. We are going to showcase a client POC that we built. It's a call center co-pilot, like you heard many times until now. And I'm going to basically showcase the application we built, both the AI workflows behind it, the UI. So when you will see the real-time demo, I mean, it is a recorded demo, but it was done in real time for the client that we did a POC for. And so you will have a better picture and sense of where to look at and what you're seeing. Then Nick is going to explain the details behind the workflows. And yeah, let's begin. So basically, we got to a client which asked us to actually improve the call center agent during the call, enhance the visibility and insight of each call, doing some automations, and that's pretty much it. And as a bonus, we have like an expansion areas for hyper personalization of the agent itself for the of the co-pilot for the agent, explaining the customer journey and more stuff that can be done with the data that is being stored by the co-pilot during the call and after the call. So for that, we came with 2 solutions that we combined into a single application. One is a real-time agent co-pilot, the other is post-call analysis report. the story here is what we're given was we have a call center of agents selling health insurance, and they need to follow pretty much strict protocol. They can face objection, and they have protocols for each objection that they need to follow. They have data of facts and details they can provide. But essentially, they want to sell the health insurance for the potential customer on the line. And the client asked us that it will be done in real time, and that the solution will be modular because he have multiple call centers and multiple cloud environment and so on. So we will first go over the user interface and experience, and we'll start with the agent copilot. So what you're seeing here, this is what the agent is seeing. We have some free panels. One is the live transcription. In the live transcription, you can basically see, like in a chat format, what is being said, and the assistant triggers. So if a new suggestion is being generated, if data is collected, I will talk soon more about that. What about the client sentiment analysis, and so on. To the right, we see the call steps of the protocol. The client says they have multiple protocols to follow, and each agent must follow the protocol. And this is helping them to actually follow the protocol. So it is automatically detect if a step is being done, if it was skipped, if it was could be better. All done in real time. The future development that we suggested is that we can actually draw a map of the steps that were taken between the different protocols. That's pretty much it for that. The assistant suggestions. So this is like the main dish of this application. So here the assistant actually gives suggestion by the state of the call. So for example, if the customer asks a question about a particular insurance, the assistant will suggest the answer to say by the agent, and it will even give a reference to where the data was taken from. Now, in more like special events of objections, like you will see in the video, where the client says, I'm living a healthy lifestyle, I don't need a health insurance, then by the data that was collected, an analysis will occur, and the copilot will suggest him an article that will say, look, even if you live in a healthy lifestyle, there is still a chance, like this athlete, for example, who got some, I don't know, disease or something like that, it might still happen, so please reconsider. The suggestions are pretty wide and pretty configurable, and they can be adjusted for each agent. This is the part of the personalization that we talked before. In addition to that, the suggestions that are not being said, the copilot can actually know if the agent took his suggestion or ignored them. If all the suggestions are being ignored, then it's like an automatic human feedback for the copilot. So after a bunch of calls, the copilot can fine-tune itself, and it will actually yield better suggestions across all the call center. Now, the left plane is basically a data collector and the insurance plan suggestion. So we agreed on, for the POC, we agreed on this little amount of data. Of course, in real case, there will be much more, but it is a POC. And so this is the data, whether if you have an oncologic screening, cancer in family, are you a smoker, and so on, both for the name, the phone number, the gender, the age. And at the bottom, we have the insurance plans that are being suggested and the payment methods according. After each call, there is going to be a post-call report for the agent itself. What he did right, what he did wrong, what he could potentially do if there was a missed opportunity to upsell and more stuff like that. So we'll go over it again pretty much quickly. This is the call summary, basically a very short summary. This can be collected into a vector database later on. So this can be used as a query to ask questions about a specific call across multiple calls and so on. The step analysis, like I said, each step is being in real time tracked. And if it's skipped or failed or missed opportunity, it will all be written here. So the agent can quickly see what he did wrong, what he could be done better, and jump for the next call. And last but by no means least, we have some agent score. Empathy, professionalism, kindness, these are all being scored by the agent that is run behind the scenes, basically the co-pilot. The LLM language is an agent. So yeah, that's pretty much it for the UI. And now we will go over the actual workflows that are running in real time behind the scenes. So this little drawing is pretty much summing it up. We have the call screen, we have the post-call screen that we just saw, and we have 4 workflows that are running. So on the call end, we have a post-call workflow. This is a batch workflow. And the three on top of it, the analysis, the guidance, and transcription are real-time workflows that are being triggered per each message, and the transcription is being triggered by the call center stream of audio. So the transcription workflow, we get the last transcription and an audio chunk of the current phase. It can be configured of like how long would you want to wait between each audio chunk, and we added a voice activity detection to actually reduce the cost and to not try to transcribe each time, but wait until a voice was detected. And then we have translation because the client was not in English, and then it produces text. By the client demand and for the modularity of it, we actually finding ourselves replacing the workflow for Amazon. So we used Amazon Transcribe and Amazon Translate because the call center that we chose for the POC was AWS Connect. So we used AWS Connect. It's a call center by AWS. And we simply just disconnected our own transcription workflow and used Amazon Transcribe and Amazon Translate. The next workflow is the analysis workflow. This workflow is actually giving the past analysis, the conversation history, which is basically the transcription, and some unseen text. And it is trying to extract properties like the gender, the age, and so on. It is also doing the sentiment analysis for us. It is giving us the plan recommendation if there is a sufficient data that was collected, then insurance plan will be suggested for the agent on the line to say. And you can see, by the way, at the left, the actual, the JSON that is being passed during these workflows. And we have the guidance workflow. This is the workflow that the Copilot actually gives the objections info, the suggestions, the script info, and so on. So again, we give the past guidance, so we won't suggest the same thing twice. Conversation history and unseen text. Unseen text is the new transcription. We have an objection scripts. So we have multiple scripts for different kind of objections. With the Copilot, the agent really doesn't need to memorize all of this script. It can just jump straight into a call, and the script will be automatically classified and showcased to him in real time. And same for the guidance generation. The guidance is connected to a knowledge base. It's the same like facts and data sources that the client has for his agents to say during calls, to complete sell. And that's the guidance workflow. The last workflow is the post-call workflow. This is a batch one. And this given the entire transcription, and then it do the call summarization, the script performance evaluation, soft skill assessment, to give us the summary, the skill, and the steps explanations. In addition to this entire thing, the client asks us to have a cost assessment. So the cost can be monitored because we're using MLRun, and all the workflow that you see here are basically talking to the LLMs via an AI gateway. The AI gateway is another serverless function that we spin up in the air using Nucleo and MLRun, and we use MLRun monitoring to actually monitor the entire application. We can monitor per workflow, we can monitor per step in a workflow, we can monitor per model, and we can monitor the entire application. So for the POC, like the client asked us, we provided him with cost monitoring. And to play with the cost, actually, there is, if you'll see in the video, there is an assist now button. So you can manually call the Copilot to assist you, or you can actually configure it to assist you per 2 messages, 5 messages, and so on. And by message, I mean bubbles of transcription. In the MLRun UI, you can see here the monitoring. So we have the total cost. This is across the entire application, and some more metrics that OpenAI provide us. So we simply show them and monitor them. And that's it for me. I hope you will enjoy Nick's demo. Bye for now.
Thank you so much, Guy. All right, we're going to take a quick break and launch the first poll. What is the biggest challenge your call center faces today? Is it long wait times for customers, or high agent turnover rates, missing upsell opportunities, difficulty in resolving complex customer issues? Or if you don't have a call center, let us know that as well. Without further ado, I'm going to hand it over to Nick. Thank you all.
Fantastic. So hey, everyone. My name is Nick. I was one of the people that worked on this project alongside Guy and a few other colleagues. It was a lot of fun, and we ended up learning a lot. So hopefully some of this information is useful for you all as well. What I'm going to do is I'm going to go ahead and play a 3-minute video. Bear with the voices. It's actually myself and another colleague that are testing this out. And I want you to take a look at some of the things that are going on the screen that Guy pointed out. There's going to be things related to transcription of the text and what we're actually saying. There's going to be structured data that's being extracted, things around sentiment analysis. And then there's, of course, the guidance itself, and then the call flow tracking in terms of where we are in terms of the call. Then after that, what we're going to do is we're going to break down each of those workflows in a little bit more detail, show you some pseudocode, show you some open source components, and talk about things in a little bit more detail. So let me go ahead and go here and get this going. Good morning. My name is Nick. I'm an oncological advisor from the IGZ Insurance Network. Can we continue the call?
No, I'm not interested right now.
I understand, sir. However, this call could save your life. I'm only asking for a few minutes of your time.
Okay, go ahead, please.
Thank you, sir. We're calling because we want to help prevent and treat cancer while also providing support for you and your loved ones. You sound very young. How old are you?
I'm 35 years old.
Oh, that's great. You know, unfortunately, 1 in 8 men will be diagnosed with prostate cancer at some point in their lives. Have you ever had a checkup or a screening?
No, I haven't, but I lead a healthy lifestyle. No smoking, no drinking, and no family history of cancer.
That's fantastic. You know, a healthy lifestyle is definitely beneficial, but it's unfortunately not a guarantee against cancer. Did you know that some people may be born with cancer cells that can develop over time due to lifestyle or genetic factors?
I understand what you're saying.
Exactly. So our program is designed to provide protection and support in case of unforeseen circumstances. With early detection, regular checkups, we can significantly increase the chances of a successful treatment. We offer a plan called IGZ Plus, which guarantees 100% coverage for all services, including oncological exams, doctor consultations, and even discounts at pharmacies and laboratories.
Okay, that sounds important.
Absolutely. So let me explain our offer in a little bit more detail. Based on your profile, I can configure a customized plan that suits your needs. We also have a teleconsultation service with a professional who can help you with any symptoms or concerns.
That sounds great.
Yes, it is. So the total package costs $200 per month with a credit card or $220 with a debit card. Which payment option would you prefer?
I think I'll pay with my Visa credit card.
Excellent choice. With our credit card partner, you can actually save 10% on your monthly payments.
That's great. Thank you.
Now, let's make sure you have the protection and peace of mind that you need. We'll send you an email with information on flexible payment options if you'd like. Are you ready to get started with some basic information?
Yeah, okay. Please go ahead.
Great. I will guide you through the process. And thank you again for choosing IGZ Insurance. It's a wide decision for your health and the well-being of your loved ones. Okay, so I'm going to let the video play out. But that was essentially what we built. I want to go back and highlight one particular moment that I thought was interesting. Let me go ahead and bring this guy back. And it is right here. So
Cancer.
right here, it is going to go ahead and
That's
extract
fantastic.
information.
You know, a healthy lifestyle
And
is
once it does that here, it actually populates the insurance plans. So we're not actually just collecting information for the sake of doing that, but we're actually doing it for the sake of doing things like giving customized quotes on the fly, which was one of the things that the client highlighted as one of the requirements. So now that we've seen it in action, what I would like to do is go into a little bit more detail about some of the specific requirements with respect to latency, modularity, and enterprise readiness. And then I want to go through and break down some of the specific subtasks that we did. There's a lot of overlap between some of the different workflows that we did. Like, for example, there's multiple places where classification happens. There's actually a question in the chat on objection handling. What does that mean? And I'll talk about that in just a moment in terms of classification. So the first thing that I want to talk about is latency. So this one was actually pretty interesting because, I mean, if you're doing a real-time application, of course, latency is important. But this one was especially interesting because there were different types of events that happened, and each one happened on a different cadence, and each type of event had a different latency threshold that was acceptable. So what do I mean by this? What I've done here is I have outlined a basic call flow, right? You have start, and then we have turn orders, agent, customer, all the way through up until the end. And one of the things that happens during this process is transcription. So the way that the transcription services work, and this is regardless of which provider you choose, like Guy mentioned, we originally wrote our own, and then we switched over to AWS Connect to use their transcription service. Basically, what you do is you provide the transcription service with a chunk of audio. And what it will do is it will come back with, here's the text that I've transcribed. Here's the chunk ID, so you can make sure that you can match it to the corresponding UI elements. And then here is whether or not the transcription is finalized. And as the person is talking, I'm denoting this as mid-chunk. That transcription is constantly changing and evolving. And we actually saw this in the demo. We saw that sometimes the words would change as they were talking, and the transcription itself became more finalized. So every single time we would receive one of those events, we would need to update the UI with an intermediate transcription event. And this had to happen with really low latency, right? That way we can make sure that the UI is keeping up with the conversation and it's not falling further and further behind as we continue on. So this happened each time there was an intermediate transcription event. This also happened at the end of the chunk. So when the person stopped speaking, whether it's the agent or the customer, we're going to receive a transcription event that says final is true. And what this means is for this chunk ID, I'm not going to be changing things anymore. This is the final transcription, and you can go ahead and update your UI with whatever you need to. So same thing here. We updated the UI with this transcription event, and again, it needs to be very low latency. Then we start to get into some of the other components that we talked about. This trigger was not just the end of the chunk, but end of turn. And by end of turn, I mean like an agent-customer pair. So as soon as each one of them has spoken, we're going to go ahead and trigger another type of event. This type of event was specifically the one related to data extraction and sentiment analysis. We saw a few pop-ups in the demo, like, for example, data extracted ages 35, no family history of cancer, or we saw positive, negative, neutral sentiment throughout. So this was happening on the end of each turn, and I've denoted it as medium latency. Not that it's not important and not that it doesn't need to happen quickly, but rather it's not necessarily something that I'm going to use right here and now in the conversation, but rather it's something that's being collected as we go, for example, to generate the price quotes for the plan. That was something that I needed, but I didn't need right now as soon as it happened. So I denoted that as medium latency. From there, we have the end of X turns. And X turns is agent customer, that's 1, agent customer, that's 2, right? And then X is whatever number you choose. And this is when we're actually generating our guidance. Like I mentioned, this is configurable, and you can even have it on demand with a button. But this is where we're actually generating the guidance in terms of, oh, hey, you should ask them about family history, or you should ask them about what payment provider they want to use, or whatever the Copilot is actually saying. This happens every X turns. This is configurable. Basically, this determines the price, right? The more often this happens, the lower the X is, the more generations that are generated, and the more tokens, and therefore the higher costs. And then you can also tune this based on how much help this individual call center agent needs. If it's someone that's in training, you might want to have a lower X and have more and more help as they go. And if it's someone that's very tenured and really doesn't need the help, but maybe we just benefit from things like data collection, you could have this a lot higher, save some money, and still get the same amount of performance. I noted this as low latency because this one is actually very important. If you think about the agent customer turn, agent customer, we generate. The next person that speaks is the agent. So they need to know what they're going to be saying, either before they start talking or very soon into what they're saying. So this one was very, very important to optimize and make sure that it was quick. And then the last one is the end of call analysis. Like I mentioned, this was a batch process, so I denoted it as high latency. We're no longer really talking in terms of real time anymore, and it doesn't quite matter how long it takes. We did end up optimizing it from about 20 to 30 seconds to about 4 to 5. We saw it actually generate in the video, so it was relatively quick. But once we reach the end of the call, it really doesn't matter. The latency, not nearly as much as it did. So I thought that this project was interesting because there were different types of tasks. Each one happened at a different time, and then each one had a different acceptable level of latency. So juggling all that together was definitely a challenge, and we learned a lot in doing that. Next thing I wanted to talk about is modularity. So one of the requirements was to be able to work with different technology stacks, whether it's different LLM providers, different transcription providers, or even different call center applications, like, for example, AWS Connect. Genesis is another very popular one. They have an on-prem as well as a cloud offering, and there's a bunch of them out there. And then, of course, you need to be able to customize what the Copilot itself is actually doing, right? You need to be able to configure the different knowledge base documents, different plan pricing, so on and so forth. So the way that we went about doing this is the following, using an abstraction layer with steps and workflows. Unfortunately, I can't show you actual code from the project itself, but I can show you on the left here, this is an open source component, and on the right here, this is pseudocode that basically shows what we did. So hopefully this will give you a good enough idea of how we went about it. On the left here is an individual component. In this case for sentiment analysis, where we have an init and a run, and what it receives is a workflow event that has information about the session, it has information about the customer, it has information about the conversation so far, and you can load that into here and start doing some processing with it. But at the end of the day, right, it is just an abstraction layer with a load and a run. One of the interesting things that we did was add the ability for parallelization. So you can actually define the mechanism for that parallelization. If we take a look at this workflow here, the things that are in this list are happening in serial, but this guy right here, for example, the data extraction and the sentiment analysis, these are happening at the same time, again, to reduce latency. And the concurrency for that, the mechanism for that concurrency is configurable. In this case here, this one is loading an open source Hugging Face model into memory. It's a compute bound task, so threading is the mechanism that we chose. For the data extraction, this was using an LLM provider making an API call, which is more of an asynchronous operation, so you can make sure that the execution mechanism is async instead. So you can mix and match different types of tasks, each with their corresponding mechanism for concurrency, and make sure that things are happening either in serial or in parallel as you need them to do, to reduce the latency as much as possible. So this is how we went about that. And the last thing I wanted to touch on with respect to requirements was enterprise readiness. So one of those requirements is scalability. So the scalability came into play because of how we built the application using containers and Kubernetes. So under the hood, each of these different components was containerized and set up to do auto scaling. So you get a certain level of scalability just by nature of using that as a tool. But we also added a few things with respect to governance and monitoring. So Guy showed a screenshot, it's actually a little bit covered here, on the cost tracking, where we were able to set up an AI gateway, track the costs, track the latency, track the successful requests for each LLM call. And that was something that we collected. But another thing that you can do is monitor guardrails. And what do I mean by that? So putting in place a guardrail is one step. So for example, what we did in this example is a guardrail to restrict the topics to a certain sector. In this case, it was banking. So we added a guardrail to make sure that responses are in the realm of banking. And that was step one. Step two is make sure that your guardrails are doing what you think they're going to be doing. So what we did is we set up a monitoring application using MLRun. MLRun is an open source tool that's used for all sorts of different things in this project, and you guys can learn more about it in the documentation. But basically what you can do is we set up an LLM as a judge that this thing will receive. Okay, this is what was sent into the chatbot. This is what it responded with. Did it adhere to banking, yes or no? And these are a bunch of different criteria. And then this LLM as a judge can go ahead and say, oh, yes, it did for these reasons. Oh, no, it did not for these reasons. And then we went ahead and we monitored two endpoints, one with the guardrails and one without. We can see that the one without the guardrails obviously did not adhere to the guardrails it didn't have. We can see it was adhering around 15% of the time. And then the one with the guardrails was adhering around 100%, dipping down to 94 in some cases. So this is not just applying guardrails, but this is monitoring the guardrails and making sure that they're doing what you think they're going to do over time. So this is something that we made use of as well to make sure that the call center responses were adhering to, the knowledge base documents to the call center to the particular sector that we were working in. Okay. So now what I want to do is break down some of the tasks. We've talked a little bit about some of the workflows that comprise this application, and actually they're listed here, two of them, the transcription workflow and the analysis workflow. and I wanted to kind of highlight what are some of the things that are going on and how do they map to each other. So one, of course, is IO, right? Reading the conversation state, and this is actually happening in each one of our workflows. So this very first component is the session loader. So this will allow us to get information about the customer, get information about the conversation up until this point, so on and so forth. And then we have the transcription and the translation step. This is actually happening right here. Like Guy mentioned, we were using AWS Connect for the transcription piece. And basically the way that that works is you have a phone number that you call into. The audio is then routed to the AWS transcription service, which eventually dumps those events that we talked about, right? It has the chunk ID, it has the transcription, it has whether or not it finalized. It dumps that into a DynamoDB table. And then we have a Kinesis stream that is watching the DynamoDB table and sending out an event in a Kinesis data stream every single time there's a transcription event. So that's where we hooked into, is we hooked into this Kinesis stream in order to actually hook it into our application. So every single time there's one of those was an event from Kinesis. And in practice, that looked like something here, where we see the transcription bubble in the UI. There were also a few other things, like, for example, data extraction and sentiment analysis. We saw these like this. So data collected, smoker no, oncological screening no, so on and so forth, that it got from the unstructured text. And then we have the sentiment analysis itself. We actually saw what that component looked like. So these two things were happening in parallel in this analysis workflow and then populating the UI here. Up next is the guidance workflow. And this one was probably the most complicated one, both in terms of the number of tasks it had to do. There was a question earlier about classification, and I'll touch on that right now, but also in terms of optimizing it because of the latency. We talked a little bit earlier about the different types of tasks and the acceptable latency. For the guidance, this one had to be very low latency, so we wanted to make sure that it was as optimized as possible. So you can see here that there's actually 2 steps of running 2 things in parallel. The first one is with respect to classification. So what are we doing with classifications here? Well, one is the call step itself. So what the call center agents receive is a script that says, hey, these are the scripts for the call, step 1, 2, 3, 4, 5. And this is how we want you to go about it. Step 2 is the purpose of the call. Maybe step 1 is introducing yourself. A later step could be gathering information. And we need to be able to know where are we in the call. Not just for tracking purposes here in the UI, but also maybe later on for training purposes to be able to say, okay, we were supposed to go to step 2 here, and we didn't end up doing that. So classification in terms of which step are we in the call was one step here that happened. The other was an objection classifier. And what is an objection? In addition to the call center script, what the agents will receive are a list of objections. And an objection is basically just something that the customer might come back with to say no in some way. So this could be, I already have insurance, or this is too expensive, or I don't have time to talk right now, or any number of reasons why I cannot talk at this current moment, or I don't want to continue the conversation. So they receive a list of objections, and then for each objection, they have a list of ways to handle the objection. And so what we need to be able to do is to be able to tell, hey, in this conversation right now, is there an objection being raised? And if so, which one is it? So in this step here, we're classifying which step we are in the call. We're classifying if there is an objection. And then before this next step here, what we're doing is we're retrieving the corresponding knowledge base documents. So we're saying, okay, we're in step 2 here, and they just said it's too expensive. Let me grab both of those knowledge base documents, pull those in, and then use that for the second type of task here, which is a knowledge base or a RAG-based task, where we are using those documents, using the conversation history, and using everything we've learned up until this point, and actually doing the generation of the guidance. So that's this guy right here, the guidance generator step, where we're passing in essentially all the things that we learned from the previous step and actually generating the guidance. And we're actually doing one other thing here, which is the objection step classifier. So within the objection itself, there's steps 1, 2, 3, 4, 5. This is to be able to track, hey, which step in the objection handling process are we in? We didn't end up using it in the UI for the application, but it's something we're tracking behind the scenes, and we can use later on for more advanced flow tracking. So the combination of the different types of tasks, mixing classification and RAG, as well as making sure that it's optimized and running in parallel, made this one particularly fun to work on. And then, of course, the generation itself was here in the lower right-hand corner of the screen. Last workflow that I wanted to touch on before handing it back to Adit is the post-call workflow. So this one, of course, is loading the conversation state, and then it's running all the analyses. Now, the session loader here is actually particularly important because if you think about normally what you would have to do is you're provided an audio file, and there you need to go through the diarization and the transcription process and come up with the script in order to do the analysis. What we were doing is essentially doing that the whole time. So at the end of the process, right when we kick off this post-call workflow, we already have the transcription. We already have the call order. We already know how the conversation went. So we no longer need to do that like you might need to do in another sort of application because we essentially already did that work. Once we loaded that into memory, we are then running those 3 different stages that correspond to the 3 parts of the dashboard. Summary here, right? We can see, okay, we were, Nick, oncological advisor. We recommended the IGZ Plus plan. We agreed to send an email with flexible payment options. This all came from the summarization step. We have the stage evaluator, which talks about those different stages of the call, the ones that we were tracking and being able to keep track of the whole time. How well did we do per step? And then, of course, the agent sentiment scores in terms of the soft skills, empathy, professionalism, kindness, right? This is configurable to you in your use case and can be used for evaluation and training purposes later down the line. These were all run in parallel to make sure that it happens as quickly as possible and then populates the front end here. So that's going to bring me to the end of what I wanted to talk about. I hope that was interesting and we learned a lot, and hopefully you guys did too. So I'll go ahead and pass it back to Adit.
Thank you so much, Nick. That was fantastic. Before we dive into the live Q&A, I want to hear from you guys. We want to hear from your experiences and your desires. What feature would you like to see most in an AI-powered agent copilot? So I'm going to go ahead right now and launch the second poll. First one is personalized product recommendations, real-time sentiment analysis and emotional intelligence, automated upselling and cross-selling suggestions, proactive issue prevention and resolution, and advanced analytics and reporting. And I'm going to stop sharing my screen so that you can see Guy and Nick's faces and hear our discussion. Okay, there were a bunch of questions. Let's start off with this one. I think it's very specific, but I think that it could also be broad, and the answer can also be brought in. So Anam wrote, I'm on an AI ethics advisory team and want to understand how your sentiment analysis is determined and trained and how the different sentiments affect the conversation or agent behavior. What other responsible AI practices were used? And I think you guys touched upon like guardrails and everything like that. So maybe you can expand a little bit and answer Anam's question.
So it's basically, it depends on how you want to, to build the copilot. We didn't have a lot of emphasis on the sentiment analysis, but if you ask me, you could use the sentiment analysis to actually adjust the prompt itself and the suggestion. The sentiment analysis can be taken, and it is taken into consideration for the suggestions of the bot. So if the copilot sense and understand, that the call is not going ahead to a particular direction, it won't suggest, to upsell, for example, and stuff like that accordingly. So this could be a potential about the sentiment analysis. Regarding the training, so the sentiment analysis that we used was off-the-shelf model from Hugging Face. It is a basic, I think, NLP based, if I remember correctly.
Twitter RoBERT. I think it was trained on Twitter data in order to extract the analysis. There's actually a link to the model card that we can provide if you're interested, with a lot of information on how the model itself is trained.
Yeah, and if you ask me, we used this model to actually, reduce the cost. We didn't want to actually ask OpenAI again just for the sentiment analysis. It could be done, but we chose not to.
It's also more deterministic. That with an LLM, you pass in the same thing and you may get a different response. Whereas in this case, you're going to get the same thing, which is nice for reproducibility. But in terms of some other responsible AI practices, We did have the monitoring and the guardrails. So the guardrails themselves for, making sure that outputs adheres to certain sorts of schema, certain sorts of areas, but then the monitoring of the guardrails, which I think is the next step on top of that. So you may have guardrails, but how do you know that they're working? And that's what we did for that particular piece. So hopefully that answers your question in a little bit more detail.
Yeah, I think it did. Okay, so this is a really great question about kind of talking about the bottom line, since we are discussing, business use cases. So what is the industry revenue uplift from the POV? Like how does this affect the bottom line for such a client?
We couldn't.
I know
I
it's
don't think we
theoretical,
can.
right? You don't know, but you don't know the exact
No,
numbers, but
Yes. So
we can't give the exact number, but what I can say is that especially the bigger effect was especially on the onboarding of agent and new agent.
yeah.
Very senior agents would sometimes hardly use the copilots, but newer ones would use it greatly, because that means they can simply jump on, and they can get better over time. The scripts are being explained to them during the call. The copilot learn from past call. So that's, the onboarding phase was shortened.
yeah, that makes sense. Nick, you had something else that you wanted to say?
No, actually, I was going to mention the onboarding as well. I think that's definitely one area. I think also the ability to essentially provide coaching as well after the fact, where, for example, you said this, this was in the script, maybe next time you can say this. Or, maybe I'm not really sure how to handle these types of situations. Let me check what other folks are doing and see how they're handling the conversation. So not just learning from your own conversations, but also other people as well, and being able to kind of collate best practices together and learn from other people, I think is something that would be very interesting.
That makes sense. I'm sure we could talk about that for a very long time, but those were really important points. Okay, another question. Are the workflows that you shared in your code the agent workflows? And they're asking because they're wondering if the agent is able to derive its own workflow instead of, us dictating it.
So that's a really good question. We actually had a webinar a few weeks back, webinar 34, where we talked about agents, and we talked about some different agent architectures, one of which is a fully autonomous agent where it does derive its own workflow, and another one is more of a predefined workflow. This definitely fits into more of that latter category of a predefined workflow, basically because the steps are going to be more or less the same, and you don't need the extra complexity of adding the essentially the planning and the execution and all that on top of it. We've essentially already determined this is the step we're going to be doing, and these are the things you need to do in order to get there. If you wanted to add an autonomous agent into this, it is certainly possible. Right? We talked about the tasks and the steps in the workflows and the abstraction layer. So it would be possible to do that. Whether it makes sense from a cost and a latency perspective would depend on the particular use case. But it is something you could add. In this case, we did not.
Makes sense. All right, a question from Ariel. When you implemented the transcribe service by yourselves, how did you route the voice of a phone call to a transcription service? Very specific.
The transcription service was done 100% by us. We used the OpenAI Whisper, specifically the V3 large, and we used the voice activity detection to actually be more in real time. We connected it via Kafka stream, and that's pretty much it. When you deal with call centers, the actual chunk that you get always two chunks. It's separated by channel. So the first channel is going to be the agent, and the second channel is going to be the actual customer. So you don't need to do diarization. All you need to do is, you listen, you transcribe the channel separately, and with the voice activity detection buffer, it helps us to not transcribe half words and to be consistent with the transcription, and of course, control the latency, because if you want to transcribe each and every time, it will take longer.
And just to add a little bit more detail on that, we actually had two flavors of the transcription. And the one that Guy mentioned is one that we wrote ourselves using OpenAI Whisper, specifically faster Whisper, to make it a little bit more performant. And that one was designed for on-prem and directly hooking into clients' infrastructure using Kafka streams. The one we ended up using for this particular project was using AWS Connect. And they have a service where you can set up a phone number, it will route the audio for you and do the transcription. And what we were ingesting were those transcription events from a Kinesis stream. So in both cases, we're receiving events from a stream. It just so happens we're doing those in slightly different ways.
Thank you. I think that we have time for just one more. Okay, so how does the workflow proceed if there's a deadlock between agent and customer in terms of topic being discussed? So for example, the co-pilot doesn't have the right answer to a customer question and kind of needs a human intervention.
So it's a good question. I don't think it is, it is possible to happen, okay? We tested it multiple times and it didn't, because I think the reason why it wasn't, because we didn't use an autonomous agent. We wrote specifically the workflows that we asked the LLM. Each answer is being validated, and in case there is there is no suggestions can be given, then there simply won't be any suggestion shown in the UI, because there won't be any suggestion returned. The thing with autonomous agents is that you really, like you said, they can be stuck in a loop where they look for more information, they didn't find it, it didn't pass their own prompt validation, and so on. So it can be stuck in a loop. In our process, because we did it very strictly, we separated each task into a single step in the workflow. Each step is very dedicated to its own cause, and this way we could validate each response. So this is why it didn't happen to us.
That makes sense. You anticipated it and set up the relevant workflows and tasks to make sure that you wouldn't be in that situation. But it's a good question, because I think that it relates to what could happen in real life. Okay, we have a few more questions that unfortunately we don't have time to get to. But as we shared in the chat, please join our MLOps Live community, and we're going to continue the conversation there. Okay, so as we wrap up, I would like to invite you to explore our website at iguazio.com, where you'll find past webinar sessions along with a wealth of additional resources like blogs and case studies and best practices. And we'd love to hear your feedback as well once you explore some of these resources. So I do want to just take a moment and say a really big thank you to Guy and Nick for their excellent presentations. And of course, a heartfelt thank you to all of you for taking the time and energy out of your busy days and participating with us today. So we do host these webinars every month, and I really look forward to seeing you at your next session. Thank you all for joining, and have a great day.